In this video, we're going to find the exact value of all 6 trigonometric functions evaluated at the angle alpha plus beta if sine of alpha is 3/5, knowing that alpha is in quadrant 1, and the cosine of beta is minus 2/3, being told that beta lies in quadrant number 3. Well, I love this kind of problem, and looking at alpha plus beta there, I think I'm going to have to use my addition formulas just a little bit. So I'm thinking that I know sine of alpha plus beta is the sine of alpha, the cosine of beta, plus cosine alpha sine beta. When I think about my addition and subtraction formulas for sine, I remember that the signs are the same here, right? The addition is the same, and sine, cosine sine on either side there. And I think I'll also use a difference formula for cosine. Some formula for cosine of alpha plus beta. All right, well, that formula, cosine alpha, cosine beta, my sine is the opposite, sine alpha, sine beta. Well, I already know some things to go in here. I know the sine of alpha is 3/5, so that'll go in those two places. The cosine of beta is minus 2/3, so I have something to fill into those spots. But it's like I don't have enough information yet. I need to take from here enough information to also know the cosine of alpha to fill into those two spots, and the sine of beta to fill into those two spots. So let's start off with the sine of alpha being 3/5. I'm in quadrant 1, which means I can just think about alpha living in a right triangle. Sine in that right triangle is the opposite over the hypotenuse. And of course, this is the very famous 3, 4, 5 right triangle. And if we weren't sure about that before, we could certainly use the Pythagorean theorem to find it. But now looking at that, I know that the cosine of alpha is 4/5. All right, well, looking at the information I have for cosine here, let's see if I can learn a little bit about it. Well, beta is in quadrant number 3, but I'm not going to let that stop me from thinking about a right triangle. Instead of beta, I'm going to put beta bar, the reference angle for beta. I know it has the same, I know all my trig functions have the same value at the reference angle as they do at beta, except for maybe a plus or minus. All the plus and minuses will be told to me by the fact that beta is in quadrant 3. All right, well, I'll ignore the plus or minus here, just cosine of 2/3, because I'm in a reference triangle here. The adjacent side 2. The hypotenuse 3, need to find this missing side. I'm going to call that b just for a second. Well, 3 squared 9 equals b squared plus 4. b squared is equal to 5, so b here has to be the square root of 5. The sine of beta is then root 5 over 3. If I think about the right plus or minus, I'm in quadrant 3 where sine is negative. So now I have cosine alpha, cosine beta, sine alpha, sine beta. I think I'm ready to use my formulas here, the addition and subtraction formulas for cosine and sine. All right, so the sine of alpha plus beta. Sine alpha, given to me, 3/5, times the cosine of beta, given to me, minus 2/3, plus the cosine of alpha, 4/5, times the sine of beta, minus root 5 over 3. 5 times 3 is 15. 5 times 3 is still 15. I have a common denominator of 15. Minus 2 times 3 is minus 6. And here I have minus 4 root 5. It's not the prettiest number I've ever seen, but it's the exact value of the sine of alpha plus beta. Cosine of alpha plus beta. All right, well, now I go cosine minus sine. So I have the cosine of alpha, 4/5. The cosine of beta, minus 2/3. Minus the sine of alpha, 3/5. And the sine of beta, minus root 5 over 3. Still have that common denominator of 15. If I'm choosing to make that just a little bit smaller. All right, minus 8. Negative times negative, that's going to be a positive 3 root 5. All right, well, I'm looking for all 6 trig functions evaluated at this alpha plus beta. I have 2 of them. I have sine and cosine. Fortunately, if I have sine and cosine, I can always find a tangent. So I'm going to go sine divided by cosine. I first observed that if I do multiply this by the reciprocal of this one, the 15s cancel. I just get minus 6 minus 4 root 5 all over minus 8 plus 3 root 5. Doesn't look much like a 5 there. I'm going to clean that up just a little bit. There we go. Well, if I assign cosine and tangent, of course, I can find cotangent, secant, and cosecant by taking reciprocals. Let's see if I can fit that in here. Cotangent of alpha plus beta is then this upside down, minus 8 plus 3 root 5, all over minus 6 minus 4 root 5. Secant of alpha plus beta is going to be the reciprocal of this one, of the cosine. All right, and then one more, the value of cosecant, which I know is an upside down sign. More mathematical if I call it a reciprocal, but more fun to say upside down. 15 over minus 6 minus 4 root 5. We could rationalize these if we wanted to, but we don't need to. We have found our 6 exact values at alpha plus beta using the addition and subtraction formulas for sine and cosine, and then our quotient identities and 2 reciprocal identities.